Alright, so this example requires us to find the net corrosion density, right? And we know that for us to find that, the net is basically the current density, net current density. So this is current, right? So this is current. This is actually current, right? So we know the net current density is the anodic current density minus the cathodic current density. We don't have any of these, right? But the parameters given can help us to find them, right? Where we know that potential anodic is anodic, right? And then we have log current density anodic over current density net exchange current density, right? Same for the cathodic, right? Cathodic. Then we have C, right? We have log cathodic exchange, right? Okay. The one for this one is very straightforward, right? And then we'll find the anodic from here, and then find the cathodic from this as well, right? But when we get to the cathodic, we look at something that's very subtle but very important, right? So now we start. So we've been given the anodic over potential. We have what is it? Anodic over potential, which is this. That's been given for both anodic and cathodic, right? Anodic, cathodic, right? So that will mean that we have 100 millivolts, and the units are very important, right? Millivolts, and then the B Tafel constant A, right, which is also 100, right? So we have log, now we have anodic, which we are trying to find, right? And then the current density is 10 to the power minus 2, right? Yeah, okay. And then we pay attention to the unit as well, because this is in amperes per centimeters squared, right? The answer that we get for the anodic current density will be amperes per centimeter squared as well, right? So here we can compute it very fast. This is one of many examples. Trying. So we are trying to see what this one will give us. Okay. And the formulas are very important, especially for the cathodic. When we get there, we'll see why we say it's very important. Something small. Oh yeah, so we have 100 equal to 100. We have log is 10, right? And then we have, we are trying to find, let's make it x to the power minus 2, right? All right. So this gives us the another current density 0.1, the value, right? But important, the values, the unit for this, the denominator and the numerator should be the same, right? So we have the denominator to be amperes per centimeter square. So this as well will be amperes per centimeters square, right? Okay. And then the cathodic, right? So when it gets to the cathodic, so this is for the anodic half. Cathodic. Okay, so the overpotential potential is 100 as well, right? But then let's see. See, when we were doing this, we said the overpotential potential for this is negative, right? And so this is for the cathodic side, and it is negative because the slope for this one is negative. So what actually makes the overpotential potential negative is the slope, which is the b, right? And we saw the formula for that one, that it has this negative here, right? So it's because of this negative here, that's what makes the overpotential potential negative, right? So if it comes, so the only thing you have to do is that you just have to make sure that only one of them is negative in whatever it is they are solving, right? So you have been given the overpotential potential to positive, right? Yeah, the overpotential potential is positive, and then the Tafel constant is negative, right? So that means it will work fine. To work fine. So let's see how we go about that. So we have 100 is equal to minus 100, right? Okay, and then we have log anodic over potential is 10 to the power minus, sorry, exchange current density is 10 to the power minus 2. So let's see what we get. 100, you have minus here, right? So we end up getting another current density as 0.001 amperes per centimeter squared, right? And the net current density that we are looking for, IE minus IC, will be 0.1 minus 0.001, right? So let's see. 0.1, 0.001. So that gives us 0.099, 0.099, the same unit, amperes per centimeters squared, right? So this is what we have. So that's it for this particular example.